Good day, students. Today I want to solve problem on the speed and period of rotation of the satellite. Let's see. You have Earth that is spherical, and you have the satellite revolving around the Earth in its orbit. Based on the question, for a satellite which is close to the Earth's surface, its radius of orbit may be assumed to be equal to the Earth's radius. Now, very close to the Earth, it's been assumed that the radius of the Earth is approximately equal to the radius of the satellite. Okay, the Earth approximately equal to the radius of the satellite, and the centripetal force at which is revolving around the Earth, that is the satellite, centripetal force equals mvs over re, mvs squared over re. Okay, don't forget mvs squared over re, where a centripetal acceleration equals vs squared over re. Okay, the force that keeps it revolving around the Earth, that is satellite around the Earth, is centripetal force, while the force that pull it away is the centrifugal force, opposite of centripetal force. And gravitational force of attraction, gravitational force of attraction, gravitational force of attraction F on the satellite is giving us F equals GME m over RE squared. Let's call it equation 1, where G equals gravitational constant, ME equals mass of the Earth, M equals mass of the satellite, RE equals radius of the Earth. Okay, and don't forget our expression for centripetal force equals mvs squared over re, and we have vs also as the speed of the satellite, Okay, you now equate this. Let's call this one equation 2. Equate equation 1 and 2 together. Okay, when you equate them together, you have GMEM, you have GMEM over RE squared equals MVS squared over RE. Equate them together, mass cancel the mass. You have GME over RE, R subscript E equals VS squared. Find the square root of both sides so that this square will cancel out. These two cancel the square root, along with GME subscript E over RE equals VS. Okay, and don't forget the square root. Okay, therefore VS equals square root of GME over RE. And don't forget that in this question we don't have mass of the earth, and there's an expression in our last class. We know that gravitational force of attraction is GMEM over RE squared equals to the weight and equals to the mass times center of gravity of the object, which is the satellite. The satellite has weight and is revolving around the earth, and the force of gravitation, gravitational force of attraction, has relationship with the weight of the object. Is that okay? That's why you have to equate them together. M cancel M. You have GME over RE squared equals to G. You cross multiply, you have GME equals to GRE squared. Okay, anywhere you see GME, you replace it with GRE squared, and you have it here. VS equals square root of, now you can replace let's call this one equation 3. Replace, before this, let's say replace GME equals to GRE squared in equation 3. I have VS equals square root of GRE squared over RE. One of them cancel each other. One cancel, RE cancel RE. We are left with square root of GRE. Now, therefore, velocity of escape, the speed of the satellite. So it's not velocity of escape. The speed of the satellite equals to GRE. Okay. Don't forget that the velocity of escape of the satellite is this square root of 2GRE. Is that okay? In the velocity of escape of the satellite, we have 2 at the front, but the speed of the satellite, we don't have 2. It's ordinary G and RE. Please take note. Now, let's now look for the speed of the satellite. You can either use this if you are given the gravitational constant, the mass of the earth, and the radius of the earth. But when you are not given the mass of the earth and gravitational constants, you make use of GRE. So you are having G to be 9.8 times radius of the earth, 6.4 times 10 to the power 6. When you multiply that, you have 62,720,000. When you find the square root, you have speed of the satellite to be 7,919.596 meters per second. This is the first part. Now let's go to the second part, which is to look for the period of rotation of the satellite. Okay, we have looked for the speed at which the satellite is revolving around the earth. Now I want to know the time, the period it takes to rotate around the earth. Now don't forget your angular speed equals 2 pi f where your F equals 1 over t. Now replace it back. We have angular speed equals to 2 pi times 1 over t equals to 2 pi over t. You have W equals 2 pi over t over 1. We need the period, cross multiply. Wt equals 2 pi. Divide both sides by W, which is the angular speed. Cancel out, we have the period to be 2 pi over angular speed. And don't forget that the relationship between linear speed and the angular speed is V equals to WR. Let's call it speed of the satellite, and also radius of the Earth. We need to replace the angular speed here with an expression. Divide both sides by RE cancel RE. You are left with double angular speed to be V, speed of the satellite over radius of the Earth. Let's call this one equation. Okay, let's just leave it like that. Let's call this one equation 4. Equation 4. Replace W equals Vs over Re in equation 4. We now have T equals 2 pi over, instead of writing W, put Vs over Re. Now, period equals 2 pi over 1 divided by this one, they are together, Vs over Re. Change the multiplication, you have 2 pi over 1 times Re over Vs, which is 2 pi Re over Vs. Okay, T equals 2 times, what's our pi? Giving us 3.142. Radius of the Earth, you are giving us 6.4 times 10 to the power 6 divided by velocity of the satellite, or the speed of the satellite, which is, we got it as 7,919.596. You multiply the numerator, you have 40,217,600 divided by 7,919.596. Your period now is 5,078.24 seconds. Therefore, the period of rotation of the satellite is approximately equal to 5,078 seconds. Okay, this is the period of rotation of the satellite. Don't forget that gravitational force of attraction holds all the galaxies together. God has made it in such a way that everything has to be held together by gravitational force of attraction. But why other naturally made galaxies are not they are not skipping away, because they are naturally made. But satellites is man-made. It get to a point, it got to weaken, the gravitational force of attraction on it got to weaken, and it escaped away permanently from the Earth's surface. This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.